Good afternoon. You can hear the birds chirping at the back. I have so much light at the back. Let me do this. Are we good? I hope you guys are good. I want us to check something. We have. I want us to check this. Feet. I want us to check some things. Yep. So if you're looking at this, you can see I have term 3 and it's what? I think it's 36 hours. Or maybe some can say it's, let me switch off this. And maybe some may say it's 9 weeks, right? I wanna see something. So I am live. Physical Sciences grade 12 term 3 is 36 hours. Let's go share with WhatsApp people and Facebook people. Let's go to Facebook and share with them. I wanna share on Facebook. Bear with me for a second. Yep. I think it's best if we copy this. We're good to go. Right? So if we're looking at this, term 3, we have week 1. That's 4 hours, right? So we have what? Electrical circuits. So if we're looking at electrical circuits, we have other topics where like we're going to be setting up the series, setting up the circuit in series or in parallel, right? The network with an ammeter, anchor in each branch, and external circuit, voltmeters across each resistor and branch, position switches in each branch and external circuit. Use this circuit to investigate short circuit and open circuit. That one you did grade 11, I guess. But now you might be doing that as well. Then for formal assessment, determine the internal resistance of a battery. That one we'll be doing using formulas. V is equals to IR, or V is equals to, what is voltage? Is it the current multiplied by the resistance, or is it the current divided by the resistance? Is it a ratio or is it a multiplication? Let me know in the chat. If you are in the chat, let me know what's popping. Are we having a lag or what? If we're having a lag, let me know. What else? Let's check something. I wanna share this. Share the link as well. WhatsApp. All right. So yeah, that's one. So let me just try to join this live here on my Let me use this other channel of mine. Oh, here. Can I go to the but the quality of this is not that good. Let me see. Can you guys see me? Mic testing, testing, testing. Can you guys see me? Mic testing, testing, testing. I think we're good. I think we're good. Even though it's lagging, but I think we're good. Even though it's lagging, but I think we're good. Yeah, I wanna la shapo. I guess le. Yeah. Anyway, as we were here, I was still wondering if term 3 is 36 hours. If it is, then let's see the breakdown step by step. So the week one, we have electrical circuits. As I have alluded there, or I've read there, this is what you need to be doing. Set up a series parallel network with a known resistor that you have know the properties of, or the spec. Determine the equivalent resistance using an ammeter and a voltmeter, and compare with theoretical values. Then we have what? Let me go to. Then we have what? Week 2 and 3, right? Then on week 2 and 3, we have electrics, electrical machines, generators, motors, alternating current. That's where we get in the efficiency, the power, and energy, right, of the machine that are able to pull through things, or able to use this efficient power, or this unit of joules or energy to generate electricity. And then we also have what? This is part of magnetism, right? Then we have week 4. Right now, where you guys at? Are you guys at optical phenomena? If you guys are there, let me know in the comments. As well as what optical phenomena and properties of materials, photoelectric effect, emission and absorption spectra. That's light and color. So it's matter and materials. Another topic is chemistry. That's where I'm about. So half of week 5, we have 2 hours that we need to dedicate here. But this one, it's actually for the teacher. So all these hours that we have here are for the teacher, are not for the students, are not for. This is the engagement between the student and the lecturer or a teacher. So, with that being said, I think in 9 weeks you have to cover, I would say, 9 times 36. How much is it? That's a lot. That's how much you need to cover. Because if you only engage with the teacher, got classing, and then you don't engage with yourself alone, you're gonna have big, 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 big problems. You get me. You got me. You're gonna have serious problems, my boss. You're gonna have very serious problems. I'm not gonna lie. Not gonna lie to you, man. Yeah. With electrochemical reactions and electrolyte cells and galvanized, there's certain things that you need to remember. Uh, Galvanized cells, electrolytic cell, electroplating, hinting to you the investigations of cathode and anode, what happens to the cathode and what happens to the anode. And with that being said, the teacher will let you know and will give you examples and will give you pictures. But you have to go and tackle different scenarios of questions that you may see in the question papers from 2021 to 2026, or even beyond that, right? Not beyond the years, but beyond your scope of content. So, getting higher order questions on how electroplating or electrolysis is being used, and what are the bottlenecks, and what are the advantages. All right. So yeah, then we have week 6.5 and half of 7, which needs 6 hours. Right. From this, we're gonna be doing relations to current, potential rate, and equilibrium. 1 hour. Understanding the process of redox reactions. 1 hour. Standard electrode potentials. 1 hour. Writing equations and representing oxidations. 2 hours. And then we have oxidation numbers, applications of oxidation in 1 hour. And then week 9 assessment, determine internal resistance of a battery. That's what we said in the beginning. So these are trial examinations. So prelims very soon, maybe next month, but maybe after the next month you guys will be doing that. Okay, this is term 4 now. Mechanics, electricity, magnetism, waves, sunlight, organic chemistry, and reactions. At least problems and exercises. You guys should be able to be doing that. That's some 4. For now, let's stick to this. What's the most difficult one or the most consuming one? 6 hours for electrical optics, 6 hours, 8 hours on electrodynamics. So I think we might do this one. Skip electric circuits for 4 hours and go straight to electrodynamics. Cool. All right. So electrodynamics, electrolytic cells, and come on. Oh, electrolytic cells and galvanic cells. So this side we're going to investigate the electrolysis of water and sodium iodide. Find the galvanic cell with the highest potential and investigate the reduction of metal ions and halogens. All right. So we're gonna be focusing half of our day on this, which is 2 hours. Maybe we might do 1 hour of this, and then we might go to electrochemical reactions a bit, introduce them, go back and finish electrochemical reactions. So that's about it, right? Let's go to electrochemical. Yeah, electrochemical class or like chemical change. Wait, I need to check table of content. Mm. Chapter 11, electrodynamics. Electrodynamics 224. 224. Yes, yes. These are circuits. These are still circuits. Batteries and internal resistance. These are still circuits. It says it said what 224. I think that's the end of it. The new chapter, electrodynamics. That's where we're gonna start. All right. I'm tired. What are you guys doing? Are you guys on? How are you guys feeling? So, introduction: electrical machines, generators, and motors, alternating current, and then the chapter summary. You can start here at the chapter summary, which is 227, and see what you need to know by the end of the. It's not that long. Oh, Kunji, this one is just the teacher's guide. So, introduction. So, electrical machines, generators. What? I'm trying to, you know what I'm trying to do? I'm trying to look at the most important things that most students struggle with. Cold drink. Let me pour something. Let me show you my studio. This is where I'm at. I'm actually in my PJs. This is my mic. This is my table. That's my phone. That's my iPad. That's my screen. That's my table. That's my light. That's my studio. That's my. See? It's a little bit messy, but like, yeah, it works. What are you guys doing right now? Look at that calculator. So dusty. Yeah. My name is Chrizeecry. My name is Chris. Some call me Samson. I'm a civil engineer and I'm also a STEM mentor. I teach math and science students how to solve their math equations and chemical equations and how to get through engineering school as well as life and becoming a creative, educated, and very entrepreneur, entrepreneurial. That's what I'm trying to say. So yeah, my name is Chris, and I'm your host for the most. And I'm here to stay. I hope you guys have been hearing what I've been saying, because it was a little bit far. So everyone, I'm not trying to waste your guys' time. It's getting a little bit cold. So actually, I'm trying to state the difference between generators and motors. That's not. It is important, but not that. It is important, but not that important. Definition of Faraday's law, yes, and internalizing it because it's gonna make you understand why some circuits behave some way. Using Faraday's law for explanations, the definition of a generator, explaining the principles of AC and DC generator using words and pictures, explaining the difference between AC and generators. Uh, are we are we in the right chapter? Yes, it is. Yes. But I did not want this topic. That's not what we wanted to do. I think we're supposed to do electrochemical reactions. So is it electrochemical? I forgot, but I think it is. That's what we're supposed to be doing. Mm. More topic in your hand. Redox reactions, galvanic. Yeah, I think. Yep. Yeah, we still have a lot of work to do here. Yo, bafowethu, lo tlo nyewa mo. La bona mara di a bua deep leg. Deep leg di tlo ntsha papa. Mm. So, I'm trying to look at the. Mm, let me see something. Fana ba rata dikoma. Ba rasa ka ntle ka dikoma. Let's just go look and then. I'm thinking no guy, but like, I said we have to skip this electric circuit and do electrodynamic. Elect. Eish, bafana. This and circuits have to be done at the same time because the knowledge translates very well. Eish, this kids. So ereke bona hore pila re fetsa kang so that I can let you guys come to I want you guys to come and see the short videos for this instead of doing the whole thing and it becomes a 2 hour long video. No. We have to do it in small bits and bits so that you watch it every day and then it gets concrete. It gets cemented inside. Here we go. Mhm. The best thing is to go again. Come to what you guys are doing. Doing a lot. And I was saying, Papa. Comprehension 40. Electrochemical. It's okay. We're gonna stick to that then. Chapter 13 it is, guys. It is confirmed. Chapter 13. So, revision of oxidation. Right? So, this chapter is allocated. What the fuck? 8 fucking hours. 8 fucking hours covers electrochemical reactions, the galvanic cell, the electrolytic cell, This is good for me because I'm a civil engineer, and in civil engineering, that's what we use for electroplating, like galvanized steel, or even plates, or even spoon utensils. We also do staircase rails, and then as well as you see on the mic, you see what we have, not on the mic, on the headsets. Do you see what we have? We have a silver thing there that was, it is somewhat electroplating that happened, and then also even on chains gold, a lot of things. So as a civil engineer or a chemical engineer or a mining engineer, electroplating is some of the things that you're gonna be doing a whole lot in your life, right? So you need to be understanding this. This is just 8 hours, but I think you need to put more 8 and make it 16 or even 32 or even 64 for that matter, you know, so that you can get the grasp of what's really happening in here. So, first step, we should, the first step should be to revise redox reactions, oxidation numbers for smaller redox reactions, oxidations and reductions is happening. The other one is losing, the other one is gaining the metal. That's what's happening, right? Oxidation numbers are always oxidation and reduction. Before continuing with the chapter, note that sections are not ordered in this way in CAPS document, but learners are more likely to struggle if you do not revise concepts first. It's crazy. Students are always struggling with something, but teachers are not, which is crazy. I'm kidding. I'm kidding. So, yeah, they're saying you need to revise these things first, right? I can highlight here. What's this draw? Okay. It takes time. A good understanding. The chapter ends with applications electron industry. Done. We are done here. A good understanding of these topics is essential. The chapter ends with applications of electrochemistry in industry. This is a good opportunity to make sure the learners understands principles, but it is not necessary for them to learn direction by heart or study the industry itself. Answer, you just have to understand them, not know them by heart, as I don't, and I'm your tutor. Right? So can you guys wait for me? We don't have music. No, no, nothing confusing. Let me just do this revision of oxidation, right? Kabo. For me to move faster. For me to move faster, I think we need to do revision of oxidation, reduction, reduction. It is important to revise the concepts of oxidation number. Okay. As well as how to write and balance redox reactions and half reactions, right? And understanding of this concept is very important as eh, in every aspect of this chapter. Galvanic and electrolytic cells. This section introduces the concept of an electrochemical reaction. It may be worth a brief revision of the zinc copper experiment performed in grade 11. Yes, that's the most famous one. Where like we're coating zinc with copper, right? Um, yeah. Two types of electrochemical cells are covered: galvanic cells, electrolytic cells. Galvanic cells convert chemical potential energy to electrical potential energy, while electrolytic cell convert electrical potential energy to chemical. We do like that. Galvanic cells convert chemical to electrical, and electrolytical convert electrical to chemical. As you can hear it, the first one is galvanic. So it's taking the chemical, which is the galvanic, to the electrical, which is the electrical. Matlagas. Ne? Yeah, we go on. I think so. And then we have also what? Um, processes in electrochemical cells. This section is more in depth. Look at the oxidation. Where can we find the oxidation number on the periodic table? Can someone let me know in the chat? Where can we find the oxidation number? And then I'm about to let, if any of you answers this, maybe they might get a free tutoring sessions from my website, www.chrizeecry.com, in the chat. If you know a molecular number and an oxidation number, what is an oxidation number and what is a molecular number? Geniuses, let me know in the comments. Anyway, as we go, learners should be able to draw and label a simple diagram of both of these type of cells. Write the standard cell notation for the cell. You guys know what the standard notation of a cell is, right? Right? And positive, right? That's what's happening, right? And then you should be able to draw and label a simple diagram of both types of cells. So the other one will, and there will be inside a what? A beak. Alright? Inside. I get the other one will be attaching itself to the other one, right? If you're familiar with this, good. If you're not, go back to the drawing board. Also, we have what the processes. This section is more in depth. Look at the oxidation and redox reactions taking place at the anode, right? At the cathode. What is being lost and what is being gained. Learners should be able to predict whether the electrode is the anode or cathode depending on half reactions taking place there. Also, they need to know which half reaction will take place at the anode, which will take place at the cathode, right? Effects of current and potential on rate and equilibrium. Learners should understand when a cell is flat at the reactions inside. Yeah, learners should understand that when a cell is flat, the reactions inside are in equilibrium. Like your phone, right? And the concentration of reactants and products are constant. Nothing is changing. Stagnation. There's no potential difference, and so no current can flow. Right? Nothing can flow in the cable. So nothing can happen inside the solution, right? Like, where am I? There's no potential difference, and so no current can flow, right? There's no more current. There's the more current there is, the faster the electrons are flowing, and the higher the rate of direction must be. Right? No, none of the cells they deal with in this chapter are in equilibrium, because then there will be nothing to measure. We always have to measure something. And which tool do we use to measure? A voltmeter or an ammeter, an ammeter, meter or an ammeter? Eh? Is it an ammeter or an ammeter? Yeah. Is it an ammeter or an ammeter? Let me know in the comments, guys. You guys are saying nothing. I don't know who's watching and who's not. Anyway, it's gonna be a lot of hours for this. Standard electron applications of electrochemistry. There are several experiments. Chapter learners will be using dangerous chemicals and should be properly instructed to use of safety equipment, including the safety goggles, gloves, and protective clothing. They also be reminded not to sniff any chemicals. Do not sniff any chemicals in the lab, please. Right? Wear gloves, protective goggles, and proper clothing and safety boots. They didn't closed. Nothing open. No details, a puma or anything like that. They should also be reminded not to sniff any chemicals. Don't sniff anything in the lab, whether a powder or liquid or any solid. Never take or ingest anything in the lab. Rule number one, right? As fumes can be dangerous as well. When you're mixing things, fumes can pop or smoke can be emitted from the reaction itself. So stay away from such. Um, More information on laboratory procedures as well as safety precautions is provided in chapter 1, science course. That's telling the teacher on what to be advised on. But I'd like to tell you, because you guys like to act like you adults. Right? Bakoni. Right, Bakoni. Bakoni umshat. The informal is the electrolysis of sodium iodide and water. It is very effective experiment and should be easy to perform. Learners will need to be careful as they handle experiment and should mm, as they handle concentrated sulfuric acid. It is advisable to test that current will run through the pencil before the experiment. In case the pencil lead is broken inside, if you have access to graphite rods, this can be used instead. More information for each experiment is provided in the relevant sections. So we're gonna have questions about that. That's the chapter 13. It's all theory, there's no calculations. Maybe it's gonna be fun in the lab in the class, but not here. Here is just the theory and we are just going on with it. And then we have um, oxidation number of FFE, and then we have oxidation number of Fe, and then we have gain electrons, balancing redox reactions. These are fun, but this is more like grade 11 stuff. It looks like that. Mm. We have to do this. I'm looking for the funnest way to do these things. Oh God. See, here's the thing that I was trying to tell you about. Mm-hmm. Deep, deep, deep topic. And it's all theory. But the best thing to tackle this is question papers. Right, right. I think let me see something. Where does it end? Chapter summary 13.8. Why do you have length and why do you haven't? These are possible questions. Chemical industry, nutri. Chemical industry. It's all about molecular mass, ratios, and moles. Mass ratios. It's more like grades and stuff, but it's okay. Now I see we have the framework of how many hours we need. We need at least 13. No, not 13, 36. But I was saying, how about 36 times 9? That's a lot. Anyway, um, we need to browse and check. We need to check. What's this? Fuck. Mm. Mm. Oh, we need to check the compound interest website. I need to check compound interest. Yeah, I think it's compound interest. No, not compound interest. Compound compound chem. Can't say. Compound chem. Oh, not chemicals. Chem. Here it is. Now where do we start here? this is not really good for me. Chemistry world. Let me see. Ah, this is just bullshit, bro. These are not. These are not good for studying. Let me see. These are news, bro. What? Workbook. Dot nest. Let's see. I hope we win on this one. Please. Ah, this is crazy. This is joke. The only thing that I think it's a result here. It's PHET Fed Solutions. My I have an allergy of some sort, and it's my back is itching. Maybe it's this. These are the ones that I know of. These simulations, but anything else, Mosquito Dove. It's not gonna help us with. It's not gonna help us, bro. Even I opened the wrong tab. Lab Exchange. This is a new one. I need to go to. I need to go to the one that I know of. This one. That's my boy. These are chemistry simulations. Let me look what's suitable for you for electrochemical example. Maybe I might use to explain. No, not this. it's not, and it would have been nice simulation of. Let me do this. If it's not there, then you see the anode, the cathode. So the cathode, that's where uh, we need the silver to be on. The one that we need to plate should be at the cathode. All right. So now we need to find the question. Yeah, I'm quite sleepy. You guys are probably wondering why am I so quiet? I was trying to check the question. Try to find. Oh my goodness! I'm trying to find uh, a question paper. This is 2021. I was trying to find. I'm trying to find questions pertaining electrochemical, and I think this one's not this. This is KC. I'll show you from question one. I know. This one. Two piece of magnesium reacts with this excess according to this. Which one of the following changes will increase the yield of H2? More or less. No. No. This one, no. pH. This one is electrochemical. This one is electrochemical. Which one of the following conjugate base of this? Alright. This question 1.9, 1.10. Question 4. Not really. Question 4, not really. Question 5. Somehow, but not really. Question 6. Yes. This is the one. Yeah, that's electrochemical. And then question 7. Yes, question 6 and 7. Question 8, electrochemical storage. So electrochemical has a lot. 36 hours. That 8 hours, I mean to say, of electrochemical, it's gonna be a lot. Question and actually from question 6, 7, 8, 9, 8, 9 is electrochemical. So to be sure, let's look at the questions. Define the term light. Is there pure chromium metal? Total charge transferred, right? Question 8, reducing reagent. Agent. The opposite of a reducing agent is an oxidizing agent. If it's not oxidizing, it's reducing. So those are the chemical foundation. So for us to tackle that theory, we need to go through this. Because going through that theory is a lot. But going through the questions, you can know and see where the gaps are. Question 7 also, it's also hammering on pH as well as chemical redox reaction and all that. Ka. Question 6. The electroplating equilibrium and also mass transferring. H still energy. But like yeah, it starts from question 6. The yield of moles. This one is the Le Chatelet's principle. Chemical equilibrium. Also, it starts from 8, 9. 8 and 9 is 16 and 11 marks. 16 and 11 marks. What is the most daunting question? 18, 15, 21. Question 4 is 21. Question 1 and question 4 are the most caring. Question 4 and question 1. Chemistry, paper 1. Watch out for those. Let's check another question. Paper. Ziyababa, ziyakhala. It's culling. We need to look at other question papers. Let's see. Let me stop sharing this. Start sharing where the window. Question 1 and question 4. Question 1 is 20 marks. Question 4 is 21. The rest is 18, 18, 16, 15, and all that. But if you do question 4 and question 1, you have 40, 41 out of 150. So you just need to work on that 100 on the next. Try scraping for marks. It's tough. It's tough for you boys. So this is 2025 question paper. We're just looking for paper 2 and its memo. I'm a little bit sleepy there, guys. But we need to watch or look at this. Paper 1 2025. Horiona, how was it? We're looking for electrochemical, don't forget. Oh, what's this? This paper 1. This paper 1. We're looking for we're looking at paper 2 November and checking how we can, like, we're looking at how many questions we're gonna find for electrolysis. As we have seen, how many hours are needed for term 3, and as well as from that term 3, which is 36, which is 9 weeks, there's just 8 hours of teaching electrochemical. So imagine that. It means you have your 8 times another 8 of 8 subjects, or 9 of 9 subjects, then you complete. Various options are provided, right? Let's gonna go through. Organic compounds, this compound that are not electro. We start by identifying which ones are electrochemical questions. Oh, not really. No. And the no. Products for reaction between metal oxide. Yeah. And then 1.8, I think. Concentration of each solutions is this. That's not the one. Oh, 1.9. Oxidation. Galvanic cell. You remember galvanic from chemical to electrical, and then we have electrolytic cells from electrical to chemical. Right? So now we have a galvanic cell consists of the following half cells, which is an iron and nickel. Right? Is it an iron and nickel? Yeah, I think so. So they need to know here. Question 1.9 and 1.10. That's electrochemical. So you can see that's 2 marks from question 1. So question 1 arena is 20 marks. And we're gonna look at question 4, as well as we'll be looking at the electrochemical questions. For this, no. No, question 3. No, we said question 1 and question 4 had 21 and 24 on 2021 question paper, right? November. On this one, it's 2025 question paper. So, looking at the marks, I think we have question 4, study the third organic reactions and all that from this to this, from this to that. IUPAC name. This is not electrochemical. Question 4 is not electrochemical, but how much is it? Kadi marks. Oh, that's not a trend. Then it was only for 2021. So as you can see here, we have 17 marks for question 4. For question 3 is 12 marks. For question 2, that's 22 marks. That's a lot. So it means question 1 and question 2 are the most pay questions on the paper. And then this one, how much does it pay? It pays 20. This one was for big boys. 21, 20, 20, 22. Yeah. Question 6. Saturated chemical equilibrium. Question 7. So basically question 8 and 8 and 9 are always electrochemical, and there's few questions. There's only 2 questions on question 1 for electrochemical, and there's 2 questions, question 9 and 8. So as we were checking, telling us about, I was explaining galvanic cell and electrolytic cell, and if you can go back through this video, we did explain that, and I did explain it as I was explaining that electrolytic, we're moving from electrical to chemical. So we're moving from E to C. That's electrolytic. And as you can see, we have E. We have E here to C, right? And then if we're looking for a galvanic is chemical to electrical. So this one will be a G turned into a C for chemical, and then this C will then be turned into an E. That's from chemical to electrical. This one moves from electrical to chemical. Remember that. Right? Yaphela kanjalo into yami no urapeleng. I hope you guys are good. Ne? So that's 11 marks. And then that's 11 marks. So like for electrochemical, we have, so it's 11 and 11, that's 22. Ke yona ne? 11 and 11. That's 22 plus, excuse, is it 2 marks or 4? I think it's 2 marks because that's 1.9 and 1.9 and 1.10, 2 marks. 2 marks. Yo, that's a lot. So that's 11 plus 11, that's 22 plus 4 marks, that's 15. So, what am I saying? Why am I saying 15? So it's 22 plus 4, that's 26. Right? Yeah. I'm completely out of the way. I'm sleepy. 14, 14. So gonna go to our level school no, so that you can study. Come back to school and study on this maths and science, especially this chemical stuff. But this is fun. It's actually we're talking about electricity and chemicals, and also electroplating metals, and make it match my iPad pencil. So anyway, all in all, for 2025, electrochemical was 26. And then I can tell it was 2020, 21, right? It was 21 at the bottom. Let's see. I still remember. It is 2025, that's 11. I want the other one. I want 2021 question paper. Oh, yeah. So that's 16 and 16 and 11. So that's 27. That's 27 marks. Given the so that you guys can see the window paper 2. This is 2021. That one we discovered that it's 2020. It's 26 marks for on the 2020 for chemistry. We have electrochemical amounting to 26 marks, and then on the 2021, on the 2025, it's 26 marks, and it's gonna be question 8 and 9. 8 and 9, we found out that is. I just want to get question 1. So it's 2 marks. Two. It's 4. 4 plus 4 plus 11. That's 15. 15 plus 16. That's 31. So this one had a lot of marks. 2021 had a lot of marks compared to 2025. Imagine having 30 something marks. So you are left with getting other topics right. In actual fact, everything is kind of weighing the same. It's like 35 marks, 40, and then it's super balanced. Right? So you need to know your story. I'll advise you to keep on putting more hours because these things will never put themselves inside your head. You need to be thoroughly studying. You need to be always on the grind, pursuing your maths and science topics and goals and progress. Peace.